Gates open. Seawater rushes in. After years in a shipyard, a $13 billion, 100,000-ton floating city takes its first breath of the ocean. How do you move a brand new supercarrier from dry dock to open sea without a single wrong step? Before we launch, type "launch" in the comments to back the crews who build and guide these giants, and subscribe for more real stories from life at sea. A modern aircraft carrier launch is a test of precision, not spectacle. For the crew on the bridge, launch means guiding a 100,000-ton vessel from the safety of a dry dock into open water, one careful step at a time. The word launch once meant a dramatic slide down greased ways. Today, it is a controlled float out, followed by a slow, deliberate journey through the harbor and into the sea for builders' trials. Every movement is measured. Every order is double-checked. The bridge team feels the weight of years of work and billions of dollars, knowing a single miscalculation could put lives and the ship at risk. This is not just a ship. It is a floating city, nearly 4 football fields long, with a flight deck stretching over 4.5 acres. The cost, around $13 billion, reflects the complexity packed into every inch. The launch sequence runs from the moment seawater floods the dock, through the careful undocking, to the ship's first moments under its own power at sea. There are no jets roaring overhead. There is no ceremonial bottle smashing the bow. Instead, there is a quiet tension as watchstanders monitor every gauge and call out each step. The focus is on the fundamentals: float, maneuver, and prove the basics. Only after builders' sea trials will the ship be ready for the next round of tests. Until then, every decision is about control, safety, and earning the right to call this city ready for the world's oceans. In the heart of the shipyard, construction begins with a grid of steel blocks, keel blocks set in the dry dock to bear the full weight of a 100,000-ton hull. This is where the backbone of the carrier is laid. Instead of building from the ground up in one piece, teams assemble the ship using a modular approach. Giant sections known as superlifts are prefabricated and hoisted into place by cranes that can handle hundreds of tons in a single lift. Each superlift can weigh as much as a commercial airliner and arrive at the dock with decks, bulkheads, and even some wiring already in place. These blocks fit together with less than 1 centimeter of tolerance, demanding a level of precision that leaves no room for error. As the hull grows, the carrier begins to resemble a city, block by block. Below the flight deck, a maze of corridors, compartments, and machinery rooms takes shape. The flight deck itself is roughly 4.5 acres, like the roof of a small neighborhood. Electricians and pipe fitters install enough wiring and piping to serve a small town. Miles of cable snake through the ship, connecting everything from radar to galleys. Each cable and pipe is a link in a system that will power navigation, communications, and daily life at sea. Welders and riggers, some with decades of experience, work side by side with new apprentices. Their hands, their habits, and their stories shape the metal. Their pride runs deep. Many keep journals or snap photos of final welds, knowing their names will live on in the ship's hidden spaces. The island, the ship's command tower, is set late in the build, crowning the hull with its distinctive silhouette. Every bolt, weld, and cable must be checked and rechecked before the carrier ever touches water. It stands as a single continuous structure, one seamless hull supported by its keel blocks, ready for the next test. For the riggers and builders, this is the moment when years of labor become a living ship. waiting to float free for the first time. Long before seawater touches the hull, the carrier enters a different kind of proving ground. Months of pier-side testing begin the moment the last weld cools. Shipyard engineers and Navy crew work in tandem, moving from blueprints to real systems. This is practical work. It is hands-on, and it matters because years of investment depend on what happens here. Power comes on section by section, first in controlled bursts, then across entire decks. Lights come to life down endless corridors. Miles of cable carry electricity into systems that have never run together before. Every circuit, from radar arrays to galley refrigerators, is checked and rechecked. A single unnoticed fault can cascade into bigger problems, so technicians treat each check as critical. Communication systems are brought to life next. Radios, satellite links, and internal networks are powered up and tested for reliability. Technicians run drills, simulating routine calls and emergency broadcasts. Navigation gear is calibrated, with bridge teams verifying digital charts and backup compasses. Each system needs strict certifications before it can be cleared for a move. During these months, the ship shifts from a construction site into a home. Sailors begin living aboard and learning the labyrinth of compartments and machinery. The crew grows into the vessel as shipyard specialists stay on to hand over systems. Systems engineers walk the decks with long checklists, eyes scanning for any sign of trouble. One engineer sums it up as living inside a checklist. No alarm goes uninvestigated. Even a minor anomaly triggers a chain of troubleshooting that brings together teams from the yard and the Navy. The goal is absolute. Nothing leaves the dock unproven. Only after every system passes and every emergency drill is complete does the team declare the ship ready for the next step, flooding the dock and floating free for the first time. Flooding a dry dock that holds a 100,000-ton warship is less about brute force and more about choreography. The dockmaster stands at a bank of controls, eyes moving from live readouts to the crew stationed along the length of the dock. With a nod, the order goes out. Open the primary valves. Seawater begins to surge in, tens of thousands of gallons per minute, always in calculated stages. There is no room for error. Each increment is monitored by a web of sensors, water level gauges, strain meters on the keel blocks, and digital inclinometers tracking the ship's trim and heel. The dock itself becomes a living instrument, every number checked twice. The first minutes are slow. Engineers and watchstanders scan their stations, searching for leaks, listening for the telltale hiss of air escaping as water rises around the hull. Any alarm, a pump hiccup, or a sensor out of range triggers an immediate pause, and the dockmaster's voice cuts through the radios with one word: hold. 3 teams converge to diagnose, adjust, and confirm before water moves another inch. It is like filling a stadium with seawater, but the difference between success and disaster can be measured in centimeters. As the water climbs, the ship begins to lift, ever so slightly. The load shifts from the keel blocks to the hull. Mirrors and underwater cameras confirm the first sliver of daylight between steel and stone. This is the float moment. Years of construction balanced on a tide measured by the minute. 2 independent teams call out, "All blocks clear." Only then does the dockmaster authorize the next phase. The caisson, the dock gate, as wide as a city street, remains locked until every indicator agrees that the carrier is afloat, stable, and trimmed. The ship is finally free from the land, held only by water, and by the hands of those who built her. A carrier's first motion is a dance measured in tons and seconds. 4 to 6 tugboats, each with a job as precise as a surgeon's, take up stations, 2 at the bow, 2 at the stern, and sometimes 1 or 2 more along the beam. The tug's engines idle, ready to push or pull on command. The harbor pilot, a civilian expert with decades of experience moving giants through tight spaces, climbs aboard and confers with the bridge team. Every voice on the radio is clear, clipped, and calm. The order comes, lines off. Line handlers release the heavy mooring ropes, and the carrier is no longer tied to land. Tugs nudge the hull, first with gentle pressure, then with coordinated force. The bow tugs pull the front clear of the dock mouth, while stern tugs hold the rear steady. A single misstep here, a line fouled or a tug out of position, could scrape a billion-dollar hull or jam the ship in its cradle. The channel ahead is barely wider than the carrier itself. Weather is the silent partner in this ballet. Tug masters and the pilot wait for the perfect window. Low wind, slack tide, and clear visibility. Even a mild gust can push the ship off course, so the team moves only when the numbers say go. Each tug captain keeps one eye on the carrier and one on the water, reading subtle shifts in current and wind. They speak in short commands. Bow tug, 2 ahead. Stern tug, ease to port. The bridge echoes every call, confirming orders and positions. The carrier inches forward, guided by choreography practiced in briefings, but never routine in real life. The pilot's logbook will record this as a career highlight, moving a floating city through a keyhole with no margin for error. The dock mouth widens, the last fenders slip past, and the carrier clears land for the first time. The tugs hold steady, waiting for the signal to begin the slow turn into the channel, a moment that belongs as much to human skill as to steel and horsepower. The carrier enters the channel, a steel wall moving at walking speed. 2 to 5 knots is the upper limit. Any faster, and the water's force starts to pull the hull toward the banks. This is the bank effect, a hydrodynamic risk that can grip a ship this size and drag it off course with invisible hands. The harbor pilot stands beside the commanding officer, eyes darting between the channel markers and the digital readout of the ship's draft, over 36 feet deep with only a few feet of clearance beneath the keel. Every order is crisp. Port engine ahead, 1/4. Bow tug ease to starboard. The pilot's voice, steady after decades of moving giants, cuts through the tension. There is no room for error. A sudden gust or a stray current could push 100,000 tons of steel against the channel wall. The tugs hold their positions, engines humming, ready to counter any drift. Radios crackle with short commands. The bridge team tracks every buoy, every depth sound, and every echo from the sonar. Even the smallest miscalculation can turn a routine transit into a crisis. The carrier's hull stretches nearly 1,100 feet, leaving just a sliver of space on either side as it threads the channel. On deck, watchstanders grip the rails, silent except for the call-outs of distance and bearing. The pilot's logbook will record this as a career milestone, a city at sea, balanced on a knife edge of water and judgment. Escorts pace the carrier's flanks, ready for anything. Navigation lights blink in the early light, and the city's heartbeat, its engines and its crew, pulses with anticipation. The open ocean glimmers ahead, but until the last buoy is astern, every nerve is tuned to the channel's demands. If this choreography of people and steel amazes you, subscribe. It helps us keep telling the stories behind the world's most complex ships. Salt spray hits the bow for the first time as the carrier clears the harbor and enters open water. Builders' sea trials begin, not with fanfare, but with a checklist. Shipyard engineers and Navy crew stand shoulder to shoulder, each with a clipboard or a screen, logging the ship's every move. The tests are simple, but nothing is taken for granted. The helm turns left, then right. Rudder angles are measured and compared against digital readouts. Propulsion ramps up, then down, as vibration sensors and engineers' ears both listen for anything out of place. Every course correction, every engine rev, is recorded. Discrepancy logs fill up with minor hiccups, a relay that clicks late, a pump that runs warm, a sensor out of calibration. Each is flagged for overnight review. No surprises are left to chance. The ship's initial taste of the ocean is not about speed or show. No aircraft launch, no catapult test. Instead, it is about proving that the basics work under real-world pressure. One engineer describes it as taking the ship's pulse for the first time. Shipyard and Navy teams debate findings late into the night, sorting out what needs fixing before the next trial. Only when the fundamentals are proven will the carrier move on to the next phase, earning the right to fly jets from its deck. A new aircraft carrier's journey does not end when it clears the harbor and proves it can steer, stop, and turn at sea. The next hurdle is institutional and unyielding. The Board of Inspection and Survey, called INSURV, comes aboard. This is not a single-day check. INSURV brings teams of inspectors, each an expert in systems from propulsion to combat electronics. Their job is simple and exacting: confirm that every promise on the drawing board is now a working reality. Hundreds of tests unfold over days. Some are as simple as flipping a switch. Others require running the ship at high power, while engineers watch vibration and temperature readings. Discrepancies are inevitable. A relay trips late, a sensor goes dark, or a watertight door does not fully seal. Each issue is logged and ranked by severity. Major deficiencies, anything that threatens safety or the ship's mission, must be fixed before the Navy will accept delivery. Minor flaws are tracked and scheduled for repair, and they do not stop the handover. INSURV's report becomes the ship's scorecard. The shipyard faces its final exam. Only after these findings are resolved, sometimes weeks or months later, does the Navy sign the delivery papers. For the commissioning officer, this is the moment responsibility finally shifts. The ship moves from the hands of builders to the command of its first crew. There is a handshake, and the pennant goes up. Those moments are public and symbolic. They mark a milestone, not the finish line. Workups and certifications continue long after launch day. Headlines fade. Systems are tuned. Crews practice damage control and flight deck drills. More inspections verify readiness across every deck. Full operational readiness is a process that runs through checklists and people, measured in repeated training, corrected defects, and the confidence of sailors who will live and operate on board. The human detail matters. Shipyard craft hand tools to sailors. Engineers trade data with deck watchstanders. Small teams fix problems that could have been missed in the noise of assembly. The metric is simple. Hundreds of people and thousands of work hours turn a hull into a city with a runway on top. The consequence is clear. Only with those tests, fixes, and trainings does a carrier become a reliable instrument of national strategy. A carrier's first launch is more than a technical milestone. It is a moment that binds generations. In the shipyard, the sound of the bell rings out, echoing down steel corridors and across the decks. The bell is a tradition that signals stewardship and the passing of responsibility from builders to crew. On the waterfront, Families gather in parks and along piers to search for a glimpse of the ship that has shaped their city for years. For many, this is deeply personal. A welder's daughter points to the hull section her father worked on. A retired rigger brings photos from his last day on the job, proud that his fingerprints joined thousands more in the ship's hidden spaces. The scale is hard to grasp until you stand beside her. The flight deck stretches more than 4.5 acres, enough space for 4 football fields. From bow to stern, the carrier runs nearly 1,100 feet, longer than the tallest skyscraper is high. Building her supports thousands of jobs: welders, electricians, machinists, cooks, and sailors. Each person has a role in bringing this floating city to life. On launch day, these workers and their families feel the weight of their effort in every bolt and weld. The first lines cast off are more than rope. They are a symbol. As the ship moves into open water, a community's pride and a nation's investment glide with her. The bells chime, the raised pennant, and the cheers from the shore mark a new chapter written by hands both seen and unseen. Every time a 100,000-ton carrier leaves its dock, it signals more than technology. It is a statement of readiness in a world where sea control still shapes global security. As new threats emerge, the precision and teamwork behind each launch matter more than ever. The ocean remains unpredictable, and so does the resolve of the people who build and guide these giants. Thanks for watching. Share your thoughts on what should launch next.